Welcome to the final part of the IGCSE Chemistry warm-up video for the 2018 Paper 2. I'm not quite sure who is more relieved, me or you. But we'll scroll through without further ado and get started on the final couple of questions. I'm not quite sure how I've managed to mess this up, but let's go all the way to... Although there is excuse for writing it down wrong, let's go back. Right. Are we all ready? These kind of questions have become increasingly popular in the last couple of years. So the examiners give a number of organic compounds and then a series of questions after them. And you're supposed to obviously pick which molecule fits the bill in each case. So give the letter of a hydrocarbon which is not an alkene. So here we're testing whether the candidate knows what an alkene is or not. Now an alkene must have some kind of carbon-carbon double bond. So that is an alkene due to its carbon-carbon double bond. That is an alkene. That is an alkene. That is an alkene. But C and F are not alkenes. So C would be reasonable, F is a reasonable answer there. Now, next question. Which two are isomers? So isomers, same molecular formula, different structure. And initially that's a little bit tricky. But if you look at A and B, you'll see that both A and B contain 4 carbons, and they all contain 8 hydrogens. But in A, the double bond is off the first carbon, and in B, the double bond is between the middle two. So they've got the same molecular formula, but a different structure. So it's A and B. And which structure is propene? Well, you should know that propene is going to have 3 carbons because of the prop at the start, and the ene tells you it's got a double bond. So which structure has 3 carbons and a double bond? It must be E. Now, hydrocarbon D forms a polymer. Draw the structure and name it. Well, the name of the polymer is going to be polyethene. And normally we'd put the ethene in brackets. Now, it's ethene because there's only 2 carbons in the formula, and the structure of the polymer shows you the 2 carbons there. Looks horrendous, I'm afraid, due to my writing. And if I just left it at that, I certainly wouldn't get the mark, or all the marks, because I've missed off the N. And that's a really easy mistake to make. So many times I'm marking mock exams, and I see the student has forgotten to write the N. So please be aware of that. Now, this is a lovely old question about sulfur that used to be on the syllabus, and sulfur forms these wonderful molecules made up of 8 atoms. So the actual I've managed to give away the answer to the first question. What's the formula of one molecule of sulfur? It's S8. Now, even though this isn't on the syllabus anymore, I've picked this because the questions are still relevant. So what's meant by the lines? Well, if this is a complete molecule, here, holding the molecule together, we've got covalent bonds. And these bonds are nice and strong. Between this molecule and this molecule over here, you've got a kind of attraction here. And those attractions are very weak. They're known as weak intermolecular forces. So what's meant by the lines? 1, that's a covalent bond. And what's number 2, or II? That's an intermolecular force, or an IMF for short. Don't ever write IMF in an exam, write intermolecular force. Obviously, inter meaning between, molecular force. Now, sulfur, as you do know, or you should know, is used to produce sulfuric acid. And the key part of this process, according to the examiners, is the conversion of sulfur dioxide into sulfur trioxide. And so they've asked you for a chemical equation. So we've got SO2. We need to form SO3. And we do that by adding oxygen. Now, you might think, okay, bang, we're going to put a straightforward arrow in there, but please don't forget that this is actually a reversible reaction. And you might be thinking you're done, but unfortunately you've got to balance it, and the oxygens weren't balanced, so we need 2 and 2. That gives us 6 oxygens on the left and 6 oxygens on the right. And the next question is a straight knowledge recall question, really. Just asking you to trot out the conditions for this reaction, which are listed in the syllabus. So there's no excuse for not knowing. Here, where I was, and we are going to have 450 degrees C, 2 atmospheres pressure, and a catalyst of vanadium pentoxide. So that should say V2O5. And those are 3 key conditions. I'm aware that this doesn't look very neat. Atoms or atmospheres there. But that's really straight knowledge recall on that question. And here's our penultimate sheet. Draw a diagram to show the arrangement of electrons in a magnesium ion showing its charge. Well, magnesium, you need to find that on the periodic table. It's in group 2 and it has an atomic number of 12. Now, because it's in group 2, when it forms an ion, it'll lose 2 electrons, so we'll only have 10 electrons, and those electrons are going to be rearranged. So we've got 2 on the inner shell, and then the next shell you can fit 8. And because it's lost 2 electrons, that gives it a 2+ charge. Now, I really like this question. Why does magnesium fluoride have a higher melting point than sodium fluoride? And it's all to do with, obviously, the difference between magnesium and sodium in this compound. While magnesium forms Mg2+ ions, as we've already discussed, sodium forms Na+. And so within this giant ionic lattice, the fluorine ions are going to attract, the magnesium ions are going to attract the fluoride ions far stronger than the sodium ions would do, because magnesium has double the charge. And so it might not be fair to say it's got double the attraction, but it's certainly got significantly more attraction than the single positive charge. And that's what you need to explain down here. I'm not going to write that down because I'm having such trouble with the pen. And the final question is a nice straightforward one to finish. Draw a cross and dot diagram to show the covalent bonding in a methane molecule. And I hope that everybody will be remembering that methane is CH4, and this really isn't a particularly good moment to be worrying about my drawing with this pen, but you can find carbon in the periodic table, and carbon is in group 4, so here is carbon, and we'll have 4 electrons in the outer shell here, this is where the hydrogen bonds. We've got 4 of these hydrogens. Each of which contributing an electron. And voila. Okay, that is the cross and dot diagram for a methane molecule. I've only shown the outer shell of the carbon. Strictly speaking, there should be another 2 electrons on the inner shell, but I don't think that would be needed for the marks. I hope the videos have proved useful. I'm really sorry that my writing, I've been really struggling to use the program and the iPad. Maybe the iPad's getting old, or maybe it's me getting old, but I hope they've proved useful, and very best of luck with all your exams.